We've got some fresh images of 3I Atlas, a third ever interstellar object.
We've never seen anything like this in the solar system before.
In early August 2025, a technician at the James Webb Space Telescope noticed something they couldn't explain. A faint pulse kept appearing in the data from Webb's near-infrared instruments. At first, it seemed like background noise, but the rhythm was too precise, too deliberate. Analysts tried recalibrations, yet the signal just wouldn't vanish. It repeated with machine-like accuracy, unlike any natural source we've ever seen.
Different scientists have analysed the data, so the scientific data does point to it actually being some artificial creation.
Within days, other telescopes confirmed the anomaly. And suddenly, what began as a routine check quickly turned into one of the most unsettling discoveries ever linked to an interstellar visitor.
This is a raw image, so this is not even this is just directly from the telescope right now.
You're looking at a piece of what would have become a planet in another star system. This is a building block from somebody else's home.
The discovery. On July 1st, 2025, astronomers at the Atlas Survey Telescope in Chile noticed something unusual.
3I Atlas was discovered on July 1st by the NASA-funded Atlas survey. It was discovered using their telescope at Rio Hurtado in Chile, and it was first detected as a speck of light moving relative to background stars.
A faint dot of light was moving against the background stars, and its path didn't fit the motion of regular comets or asteroids. The Minor Planet Center quickly flagged it as a hyperbolic object, meaning it wasn't bound to the Sun. Instead, it was coming from interstellar space. This new visitor was given the designation 3E/ATLAS, making it the third confirmed interstellar object ever discovered, after Oumuamua in 2017 and 2I/Borisov in 2019. The first interstellar object, Oumuamua, was discovered in 2017. Its strange shape and unexplainable acceleration shocked the world.
It's shaped like a cigar. It's maybe 5 or 10 times as long as it is across. No asteroid that we know of looks like a cigar. Inevitably, there were people who said, well, are you sure it's a rock?
Then, 2 years later, in 2018, it happened again. 2I/Borisov appeared, resembling a more traditional comet. Now, 6 years after that, 3I/ATLAS has also entered the stage, but it stands apart from both its predecessors in nearly every way. Scientists knew immediately that this was rare. Interstellar objects do not come by very often. Our solar system may only get a handful of such visitors in a human lifetime. What made 3I/ATLAS even more interesting was its early detection. Unlike Oumuamua, which was already speeding away by the time telescopes noticed it, 3I/ATLAS was spotted months before its closest approach. That meant scientists had precious time to study it in detail. The next step was to confirm its orbit. Astronomers pulled older data from other telescopes, including the Transiting Exoplanet Survey Satellite, TESS, and the Zwicky Transient Facility, ZTF. By tracing it back into mid-June, they built a clear picture of its journey. The orbit was undeniably hyperbolic, with an eccentricity greater than 1. That single number confirmed it. 3I/ATLAS came from beyond our Sun's gravity and would never return once it passed through. Its inbound path is also remarkable. The object isn't just wandering in, it's sliding almost perfectly along the solar system's ecliptic plane, the same flat disk where planets orbit. That alignment is unusual. Statistically, an interstellar body should approach from a random angle, not neatly thread through the middle of our system. For many astronomers, that near-perfect alignment is surprising. This is because many orbital simulations suggest the odds of such alignment is extremely low, making the near-perfect alignment of the 3I/ATLAS a rarity. Estimates of its size make this occurrence even more interesting. Based on its brightness, 3E/ATLAS is said to be between 3 and 7 miles across, much larger than either of its predecessors, Oumuamua and Borisov. Oumuamua was cigar-shaped but tiny, less than half a mile long. Borisov was a bit bigger, but still nowhere near the scale of ATLAS. Scientists weren't just dealing with any wandering rock. They were looking at something closer in scale to a small moon, cruising in from interstellar space. New insights from dynamical studies now suggest that 3I/ATLAS may have been traveling through the galaxy for billions of years, possibly longer than our solar system has existed.
Because it's only the third time we've ever seen an interstellar object. And interstellar doesn't just mean Matthew McConaughey, it means something not from our solar system. It's interstellar, it's between suns.
So, how has it wound up here then? Well, it may have been ejected from a distant star system during the early stages of planet formation and has been drifting ever since. In that time, cosmic radiation, collisions with tiny dust grains, and the emptiness of space may have stripped away or altered its surface. In essence, what we're seeing today could be a survivor from an alien world that no longer exists. By late October, 3I/ATLAS will reach its perihelion, or, in other words, closest point to the Sun, deep inside the orbit of Mars. From there, it will swing back out, never to return. Right now, though, it offers astronomers a rare window, a chance to study in real time a piece of another star system, captured only for a brief moment in human history.
It may well be just a rock which has some ice on the surface that evaporates.
Chemical and structural mysteries. When scientists first got clear spectra from the James Webb Space Telescope, JWST, and from SPHEREX, they thought they knew what to expect. Every comet or icy body we've seen so far, when warmed by solar light, shows outgassing of water vapor, carbon monoxide, CO, methane, or other small volatiles. But 3E/ATLAS wasn't behaving like any normal comet. The spectra show nearly exclusive carbon dioxide, CO2, emissions which are very bright, sharply defined lines in the infrared. Water vapor lines, which are usually among the strongest signals for comets inside 6 astronomical units, often roughly over 500 million miles from the Sun, were absent. Carbon monoxide, methane, ammonia, essentially every other expected molecule, were missing or buried in noise. This pure carbon dioxide output is rare, and this breaks the standard comet model. Normally, volatile ices sublimate in stages. Near the outer solar system, CO or CO2 may release first. Then closer in, water vapor dominates. But Atlas seems to skip all that. It vents CO2 strongly, even at a large distance from the Sun. Laboratory simulations of ice mixtures under cosmic radiation show CO2 layers can form a crust over more volatile ices, suppressing water vapor release until the crust is disrupted. In some cases, CO and water may be trapped beneath such a layer, never escaping. It's possible 3I/ATLAS has a thick surface coating or processed skin that allows only CO2 to escape, either by diffusion or through cracks. In standard cometary science, each molecule has a temperature threshold and a vapor pressure curve. For water, for example, sublimation is negligible beyond a few astronomical units. However, CO2 has lower volatility but still requires certain energy input. That Atlas is active so far from the Sun suggests either it has a higher internal heat than expected, or its surface is unusually efficient at capturing sunlight and converting it to heat. Some modeling suggests that dust grains with dark carbon-rich material, or even metallic dust, can absorb sunlight more effectively and transport heat inward, warming deeper layers. If 3I/ATLAS is covered with such dark material, Its surface may trap heat and cause CO2 to sublimate even when solar input is weak. This also raises questions about longevity. If it had been traveling through interstellar space for billions of years, cosmic rays, micrometeorite impacts, and UV radiation would degrade volatile ices. That means much of what was once volatile may already be lost, leaving behind the more resilient CO2. In fact, simulations of interstellar aging show that molecules such as CO and water ice are more easily sputtered away or broken down, while CO2 and more stable compounds survive. So, what scientists currently observe to be volatile ices may indeed be a processed shell rather than pristine material. In the August session, JWST collected imaging and spectrographic data under the public archive embargo. The frames show a concentric halo of CO2 emission, rings of light, evenly spaced radiance centered on the nucleus. In the heart of that halo, infrared brightness spiked, indicating a central hotspot that is much hotter or more active than the rest of the surface. The symmetry is extraordinary. No obvious tails, no jets or plumes breaking the circle, nothing to spoil the perfect shell of emission. This kind of morphological structure is almost unheard of. Most comets show irregularities such as jets, outflows, dust tails, gas asymmetries, all of which are shaped by sunlight or solar wind. But even after ATLAS has been subjected to different orientations across different instruments and configurations, it still maintains itself in every exposure. Simulation work in astrophysics shows that to maintain such symmetry, the structure must be either uniformly active over a spherical surface, or else there must be a mechanism of regulating outputs like vents or pores distributed evenly. It suggests either naturally uniform surface properties or possibly structural engineering if we give room for speculation to maintain that regularity. Another structural oddity is that each exposure reveals a straight, rotating band of darkness crossing the nucleus. The band moves in step with the object's rotation, always tracing the same axis. It's not a dust jet, not a shadow from external solar objects. It's intrinsic to the body. For a shadow to persist across the coma and move with rotation suggests that beneath the surface there is something dense enough to block infrared light, a shell or internal structure of higher opacity. The dark band suggests that the interior could be completely hollow or partly hollow. Putting it all together, when you combine the chemical oddity, that is, the pure CO2 outgassing with structural anomalies such as the halo, central hotspot, and rotating dark band, you get a picture of an object that does not match known comet behavior. And that has left the science community hypothesizing. Is ATLAS a natural object with an unusual formation history? Perhaps from a star system with little water, highly irradiated with dust covering, which lost its more volatile ices early? Or could it be something more exotic? A body with engineered structure, intentionally or unintentionally shielding certain volatiles, controlling emission, maintaining symmetry. This is speculative, but many scientists note that the data forces speculation. Ultimately, regardless of which hypothesis one favors, there are two unavoidable questions. What is this made of? And how did it get to be this way? As ATLAS moves toward perihelion, these structural and chemical clues may reveal themselves more clearly, and the answers could challenge decades of comet science. Signals and countdown patterns. When the chemical and structural mysteries of 3I/ATLAS started piling up, scientists noticed something else that was just as unusual. And those were the rhythmic signals, patterns that seemed to follow deliberate logic rather than chaos. What was observed? What does it mean? And why do many experts believe this goes beyond natural processes? Shortly after the first infrared spectra, analysts studying the time series output from JWST discovered a pattern of pulses at regular intervals. The pulses occurred every 2, 3, 5, 7, and 11 seconds. These are all prime numbers. Prime numbers are integers greater than 1 that are divisible only by 1 and themselves. SETI, the body for the search for extraterrestrial intelligence, considers prime numbers as universal markers. What makes these pulses even more striking is the fact that they aren't transient noise. The sequence repeated in every exposure, under different instrument settings. They do not arise from cosmic ray hits, sensor artifacts, or interference. The data pipelines, calibration routines, background subtraction, all of them failed to eliminate the pattern. This led analysts to begin to suspect that this was intentional, that Atlas must be carrying an encoded message, perhaps using prime numbers as a universal language. Interestingly, the pattern didn't stay static. Over time, it evolved. Scientists tracked phases in the pulse sequence. At phase 1, simple single pulses separated by prime intervals, 2, 3, 5, 7, 11 seconds. By phase 2, there were paired pulses, or double bursts, separated by the same prime-based schedule. At phase 3, a group of 5 pattern repeats every 283 seconds. Then, phase 4 and phase 5 appear to be looming. This evolution suggests that the message encoded in ATLAS, if it has a message at all, must be layered. But whether it is layered or not, it is clear that the signal is far from static. This phased behavior actually mirrors technological protocols on Earth, where a device cycles through modes. For example, initiating handshake, data output, status updates. If this is a beacon or machine, the changing pulse pattern could correspond to different states such as idle, alert, message, etc. Alternatively, the phases might encode multi-part information, prime numbers as base, then grouping to transmit address or map data. One of the most classic markers in SETI theories is the hydrogen line, which is about 1,420 megahertz, or the 21-centimeter emission of neutral hydrogen. Because hydrogen is the most abundant element in the universe, many SETI strategies assume that any intelligent emitter would use that frequency to reach observers who monitor that band. In the case of 3I/ATLAS, radio telescopes monitoring its path recorded a recurring signal every 12 hours and 3 minutes tied to the hydrogen line frequency. Each time this interval passed, a pulse would appear exactly in that band. It's not clear if the frequency is shifted slightly by a Doppler effect due to the object's motion, but the recurrence is precise. Many phenomena vary with the environment. As the object moves, solar wind, magnetic fields, collisions with dust, all these can shift frequency, modulate signals, break perfect periodicity. But here, the pulses at the hydrogen line recurred with a precision that startled observers. Perhaps the most dramatic claim arising from the data is this: mapping the timing and wavelength of pulses produces a crude overlay of the Triangulum galaxy, also known as M33, that appears to relate back to Earth's position. In other words, the pattern seems to be more than mere signal. It seems to be a map or code referencing a known galaxy. Now, here's what observers have noted. As those pulses occurred, wavelength shifts aligned with positions in the sky that correspond to prominent features of M33. The sequence of pulses after prime interval grouping and hydrogen line anchoring seem to create vectors or lines that, when drawn, loop back to Earth's direction. This kind of map is unusual. Natural sources do not encode visual or spatial references this way. In communication theory, such overlays could be akin to pointing, "This is where we are," or "This is where we came from." If 3I/ATLAS carries information about its origin, referencing a known galaxy makes sense as it gives context. Also, M33 is relatively nearby in cosmic terms, about 3 million light-years away. It is a galaxy sufficiently bright and known in many star catalogs. It is plausible that an intelligent emitter might use M33 in a message, because many of Earth's telescopes already image it frequently. And there's yet another new line of thought. These pulse maps may encode not just spatial reference, but temporal positioning. Earth's own position in its orbit might be implied, so that recipients can locate sender in space and time. If the pulse frequency, prime intervals, and phase changes correspond to Earth's calendar cycles of days and years, the map overlay becomes a combined spatial and temporal address. Given all these elements, the prime number pulses, evolving phases, hydrogen line recurrence, map overlay, scientists are deeply divided. On one side is the natural hypothesis, which posits that unknown astrophysical processes such as masers, magnetars, dust amplification could produce regular pulses and narrow-band signals. But so far, no models reproduce prime interval sequences, phase evolution of this specific kind, and map overlays. Another possibility is some kind of unknown instrument artifact or data processing anomaly. But cross-checks, independent instruments, and multiple observers make that less likely. On the other side is the artificial or engineering hypothesis, which holds that the signal is a beacon, or at least an encoded message. Prime numbers are used deliberately. The hydrogen line suggests communication frequency. Map overlay uses known astronomical objects. Phased timing gives structure. If so, 3I/ATLAS might carry a kind of message or simply broadcast that it exists, from where it came, and maybe some pattern trying to connect to other intelligences. It needs to be noted that some theorists are comparing the structure of these pulses to existing human-made communications, such as synchronized satellite beacons, radar bursts, or ultra-long baseline signals. The idea of an interstellar object broadcasting structured signals carries weight. If this is artificial, it may be humanity's first encounter with something not just passing through, but trying to communicate. But there are dangers in jumping to conclusions. False positives in SETI history abound. The famous WOW signal from 1977 happened near the hydrogen line, causing widespread excitement, but has never been repeated. Natural sources or even Earth-based interference sometimes masquerade as meaningful signals. Besides, confirming a message or intent requires reproducibility. Can we see the same prime sequence again? Can other telescopes detect matching hydrogen line volleys? Can the overlay of M33 be replicated in independent frames? Secrecy and government involvement. The discovery of 3I/ATLAS had already broken scientific expectations. But what has added to the intrigue of its discovery aren't just the mysteries of 3I/ATLAS themselves.
This object has just been discovered. 3I Atlas was discovered on July 1st by the NASA-funded Atlas survey.
But the way governments and agencies move to control the flow of information. What began as an open-source scientific observation quickly turned into a tightly controlled, classified matter. In the first weeks, anyone could access the telescope data. James Webb's raw exposures, Spherex spectra, and ground-based imaging from observatories in Hawaii, Chile, and Spain were archived in their usual databases. Researchers were downloading the files daily, comparing spectral lines, and confirming trajectory models. But by mid-July, users began to notice something unusual. Entire sequences linked to 3I/ATLAS had disappeared. At first, people assumed it was a server issue. Data was sometimes delayed, flagged for calibration, or moved between archives. Yet this time was different. Every image, every spectrum connected to 3I/ATLAS was either removed or replaced with blank placeholders. Requests for clarification received only vague replies. Files under review, calibration pending, or data unavailable at this time. But the pattern seemed too orchestrated to ignore. Interestingly, normal comet observations of Hale-Bopp, Encke, or random near-Earth asteroids all remained untouched. Only ATLAS data was stripped away. The conclusion was clear and unmistakable. Agencies had classified everything related to 3I/ATLAS. What had been open science had now become state property. And as expected, scientists began to talk. Senior astronomers, some with decades of experience on cometary studies, began to share private memos through secure channels. These memos circulated in small groups, encrypted and often marked with phrases like, "Do not forward" or "internal only." Inside them were troubling details about how the pulse emissions followed prime number intervals of 2, 3, 5, 7, and 11 seconds, which is impossible to explain as random. Also included are reports that trajectory models no longer fit cleanly. Small deviations suggested something unnatural. Yet in public, these same astronomers denied everything. Journalists reached out, hoping for interviews, but replies were short and direct. No comments. At conferences, speakers would skip over slides, labeling 3I/ATLAS as inconclusive. Some who had once been eager for publicity now refused all media appearances. The contrast was striking. Privately, they admitted something extraordinary was happening. Publicly, they kept silent. The pattern felt coordinated, as if higher authorities had instructed them to maintain secrecy. While scientists kept things in a hush, militaries acted. The United States made the first visible move. Without the usual fanfare, the X-37B spaceplane was launched again.
The U.S. military's X-37B space aircraft has completed its 6th record-breaking flight.
In earlier missions, these launches had been at least partially public. Images of liftoff, press briefings, speculation about onboard experiments. This time, there was nothing. No televised countdown, no NASA commentary, just a sudden absence of the vehicle from its hangar, and a notation on classified tracking lists. Independent trackers eventually pieced together its trajectory. The spaceplane had been placed on a path that extended toward the Mars-Earth corridor, the very space Atlas was predicted to pass through later in the year.
The unique interstellar comet known as 3I Atlas is expected to pass closest to the Sun between the orbits of Mars and Earth.
Why send a military spaceplane there? Could it mean that its bay could house deep space sensors, meant to study ATLAS up close? Or could it carry defensive technologies like lasers, high-gain antennas, or experimental weapons? Or, more simply, was it meant to shadow ATLAS, gathering intelligence in real time? These are all speculations made by analysts. Whatever the purpose, the secrecy spoke volumes. If the object were harmless, a routine cometary visitor, why involve the military at all? Other powers soon mirrored this behavior. China's Tianwen-1 mission to Mars also has a high-resolution camera that can be used to monitor the comet while it passes by. Other observers have also noted adjustments in ground stations in Russia's orbital telescopes, retasked toward ATLAS. Clearly, ATLAS is no longer just an astronomical object. It was now a strategic matter. As militaries mobilized, orbital analysts noticed something even more alarming, which was that Atlas seemed to be displaying self-correcting movements. When radiation pressure nudged it slightly off course, the object adjusted. When gravitational influences shifted its velocity, compensations appeared within hours. The corrections weren't random. They looked as if it was being actively guided. At first, they do not seem to be huge shifts. Mostly fractions of degrees and subtle accelerations. But when measured across weeks, the pattern became clear. The object was steering itself. If this is true, then ATLAS seems to be under some sort of control. But it could be through advanced natural physics we don't yet understand, or by deliberate engineered means. Another unsettling thing was what happened to our oldest spacecraft Voyagers 1 and 2, still faintly transmitting decades after launch. The two spacecraft suddenly experienced signal dropouts. Pioneers 10 and 11, other probes long past their prime, also showed the same pattern. The dropouts were brief, ranging from a few minutes to hours, but they were synchronized. Each time, the interruptions occurred when the probe's line of sight aligned near AT/LAS. Then, as alignment shifted, the signals returned, normal and undisturbed. Engineers ruled out solar flares, hardware failure, or background noise. These probes had been stable for years. Only one factor changed: their alignment with AT/LAS. This was when they made a chilling realization that the object seemed capable of interfering with our spacecraft. Whether intentional jamming, field effects, or some unknown interaction, the timing was too precise to dismiss. But why the secrecy? Is it purely for each country to gain a strategic edge? Might world leaders fear chaos if people believed an intelligent interstellar probe was approaching? Let us know what you think in the comments section below. And before you leave, check out our video on Voyager 2 and how it just shocked the world.